I'm Teator. I'm an assistant professor in the chemistry department here at KU, and I went to the University of Nevada. I got a bachelor's degree in chemistry before going on to the University of Texas at Austin, where I did my PhD in organic chemistry, mostly organic synthesis, some catalysis, and in photochemistry. I didn't make any polymers at all, although I did go and do a postdoc at University of North Carolina, Chapel Hill, which was entirely in polymer synthesis. So now my group here at KU focuses on sort of a blend of organic chemistry and polymer chemistry. Our research group really lies at the intersection of organic chemistry and material science. And so we build new plastics, which we call polymers, that have properties sort of beyond what's available today. And so we do this in all of the ways one could. So we develop new chemical reactions. We design new building blocks that will become plastics later, and we do reactions that try to tune the properties or the structure of plastics after they're already made. We do this for a number of reasons, but the overarching goal is really to create new materials that can address modern societal issues, like can we make plastics more sustainable? Can we increase performance in areas like aerospace and electronics? And even can we develop new biomedical applications for polymers? And so all of these projects require a combination of skills, things from physical organic chemistry to materials characterization and polymer synthesis. So students working on these really gain a whole host of skills. Students are really the heart of research, I guess I would say. They're not really assistants or lab workers in my lab. They really own the projects, and they're the ones that drive the projects forward. And so I really view myself as trying to help them learn and grow into independent thinkers, independent scientists, by giving them mentorship and skills and tools that they can use to really address these challenging scientific problems. Polymer chemistry is quite interdisciplinary and quite employable. There are polymer jobs in oil and gas, in plastics, in cosmetics, in paint, and all sorts of different areas. And so, I would say that students that leave my group have a whole host of skills, all the way from organic chemistry to polymer science, which is really helpful for them when they're searching for the next thing they want to do. Thus far at KU, we've been involved working with a number of different groups. We have some projects with the Center for Environmentally Beneficial Catalysis, the CEBC. We have a collaboration on using some of our polymers as antimicrobial materials, which is interdivisional in our department. And we have some other collaborations in engineering that we're just starting out now about materials performance. We use all of the, typical characterization facilities. So we use the mass spec facility. We use the NMR facility pretty heavily. We have used the synthetic chemical biology core, especially their MALDI instrument. And we do have a number of sort of facilities in our own lab. So we have several polymer characterization instruments that are in-house to us. And so 2 that help us measure how big our polymers are, and 2 that help measure thermal properties, like when polymers start to degrade or when they undergo phase transition.